So, and thank you, Professor Panda. This is, I think, I was not even familiar before you called me that something in maths education, JNU would be hosting something in maths education as well. So, um, I really thrilled to know that the vistas of JNU are expanding even to maths education. And this, when I'm saying this, I am drawn to one of my experiences when I wanted to do PhD in maths education. Doesn't have mathematics as a subject, and I will not be able to find a supervisor. So it's like a circle coming back, and that's what I would like to really congratulate you. And Varsha, being a research scholar of mathematics education in JNU, it's really a pretty good moment for me to rejoice and celebrate that at least we'll have good scholars in maths education from JNU as well. So when we were discussing to the audience that are here, I'll just give you a little background. Some of you, what I'm going to say, are already familiar with what I'm going to say because a lot of you are from Delhi University. I recognize your names. And thank you to all of you who've joined, my scholars who've joined in respect, I guess, and other people also who have joined on this. Most of it you must have already heard from me because this talk was primarily oriented to how mathematics is around us, how we can't ignore it, and why shouldn't we ignore it. And what draws me to this area is, even if you're not, and I'll be bilingual largely, and what I want to say is that even though you are not a person associated with mathematics, yet you will be drawn to data. We can't escape data for whatever you will be doing in your life. The national education policy also asks us to understand data. If you have any such kind of a reservation against data, then I think you need to open up your mind. That's what I've been trying to do. Just a flavor of looking how mathematics exists in and around us. That's what I like to do now. Why I say data is very important is I think that this whole thing that I've been associated with data has helped me take a lot of decisions at a prominent or an important position like handling admissions in University of Delhi. Any aspect, any decisions that have to be made cannot be made on our assumptions, on our experiences. When somebody has to put or ask you, you can't say, I've seen this and I'm seeing this trend. When you even use words like this, policymakers or anybody who has to take a decision will ask you to support this with some data. तो मतलब आप ये नहीं कह सकते कि मतलब up to because of CUET we are having so many things in the data, we are having the people coming, how many people have come from outside Delhi, how many from inside, how has it affected CBSE, how are the students taking class 12th examination, how are they appearing in CUET, whether the coaching for CUET, ये इतने सारे मेरे पास questions आते हैं. ये when I support all this with numbers, then it carries a lot of weight. Then it carries a lot of conviction. So that's what I wanted to start my talk on this preface that if you have any reservation, please open up. There are a lot of things which are there on the YouTube. Mine is one of them that I'll be speaking here in this. Largely, this has been drawn from my context and from people who I watch and I follow on various platforms. Some of them are already there. Some of them have been recreated by me on this platform, on my certain YouTube channels. But largely what I want to tell you is that mathematics is a subject that exists always around us. I'm sure ये आपने बहुत बार सुना तो होगा ही, लेकिन सब जानते हैं कि मैथ्स हमारी रोजमर्रा की जिंदगी में जी हम कमरा बनाते हैं तभी मैथमेटिक्स है, हम चेयर रखते हैं, कुर्सी रखते हैं, पानी की बोतल पीते हैं. मैं इस तरह की मैथ्स की नहीं बात कर रही हूँ, ये मैथ्स तो है ही है. लेकिन an eye for the logic and eye for the little small little things that exist around us. Those are the things that will encourage you to look at how how mathematics is around us, even in the small little things. आपने ये सुना होगा कि गणित जो है वो नेचर में भी है. आपने फिबोनाची सीरीज भी शायद सुना होगा कि फिबोनाची सीरीज होती है और उसमें भी शायद मैथमेटिक्स है और नेचर में है और स्पाइरलिंग में है जिस तरह से हो रहा है. बट is the nature giving us maths or is the maths doing nature? There is something, there is a coordination, but it's not just that. ये सिर्फ ऐसे ही नहीं है कि आप maths को ऐसे ही समझ रहे हैं. There are a lot of people who have researched on even folk mathematics, and I'm sure Professor Panda is one of them. She's worked extensively on mathematics exist in the cultures, on how people used to work with simple mathematical things. But if you are pursuing anything in mathematics, what I would like you to do is look at mathematics being related like a subject which extends throughout the life. Certain tasks which start from, let's say they call it low ceiling and goes to higher level. What are certain things which can relate, which can help us students, which can help us to know what is mathematics around us, which can bring a love for mathematics. Often I hear people, is there a noise behind me because there is some construction work going on? Can you, was there a noise behind me when I was speaking?
No, we don't hear external noise, just that the transmission is not too clear. Yes. Varsa, how is it to you? Or anybody else?
It's fine. It's okay.
Huh.
Not too clear, but
clear,
yeah.
but that's the speech. There is no noise behind. So
Yeah.
it could be your internet.
Construction work going on in the adjacent room, and there's some drilling work going on in the adjacent room. So maybe because of
Yeah,
that.
we don't hear that. I think somehow, luckily, your microphone or whatever doesn't capture that. So it's okay. We can hear you.
Your voice is clear, ma'am. Yes.
Yeah.
Okay, great. So, as I was saying that, you know, what a simple thing मैं बहुत छोटी-छोटी बातों से अगर आपसे शुरू करूँ, and then I pick up more things in this. For example, you would have seen a manhole around you. I mean, often you walked on it. Have you ever have you ever thought of why is the manhole in a circular disc shape? What if it was not in a circular disc? What if I would make it a square, a manhole or a rectangular manhole? मतलब ये छोटी छोटी जो ऑब्जर्वेशंस है ये इनके बारे में मैं बात करना चाह रही हूँ कि ये दिस एग्जिस्ट. सो मैथमेटिक्स इज इन द ऑब्जर्वेशंस व्हाट यू सी अराउंड अस. I mean, why is what do I say? Why is those big tankers which carry liquids, especially milk or petrol or gas or something, why are they into a cylindrical shape? Why are they not in those rectangular cuboidal shapes? Has this come to your mind ever? Why do you think that, you know, when you see these gobis stacked, आजकल तो आ भी रही है बहुत, those small little temples in which they stack those full gobis, cauliflowers are stacked in a certain way, and you would have seen that they don't put any thread around it to, you know, to put it tightly. It's just that they're stacked so properly that they don't dislocate themselves. Does this not give you an expression to move further? Does this not introduce a curiosity in you that how are they stacked? What is the shape of the qualifier which is asking, you know, which is helping them stack those qualifiers in certain grid that it is logged so properly that it doesn't dislocate themselves, and they cross from one state to another. I'm sure there are potholes, there are roads that they cross which are very, very unstable. These are the simple observations that I want you to put your attention at. We understand why when a mason starts the work, how does a mason start the construction of a place? Does the mason make two parallel lines to start the work, like the Euclid told us that, you know, if you look at the textbooks, there are two parallel lines, and then you draw two parallel lines, and then there is a rectangle that emerges. Do we need the idea of parallelism always to make a rectangle or a square or even in a room? Have you ever, you know, seen those masons making it up? Or a simple thing like, you know, going beyond to what you're doing. For example, I'm sure you would have read this in your course book also, that if I take a rectangle and if I join that one edge to another edge, this will create a cylindrical. That's not a big thing to obviously imagine कि अगर एक पेज होगा उसको मैं ऐसे करके ज्वाइन कर दूंगी तो हमें एक सिलिंड्रिकल शेप मिल जाएगी. अच्छा, अब क्या होगा कि अगर मैं उस पेज में अगर मैं उसको डायगनली एक तार लगा दूं और उसको फिर एक रोटेशन से करूं, what is the shape that I'll get? Are you getting it? I have a rectangular piece, for example, this rectangular piece. If I rotate it from this edge, what I'll get is swept. Do it from here also, I will get a cylindrical. What if I, put a wire here diagonally and I rotate it like this? This will also give me a three-dimensional shape. What shape will I get? What if I break it from middle and then I do the same thing? What if the axis of rotation is not even a straight line? What if the axis of rotation is a zigzag line or is a curve? Like for example, here itself, if I put a curve on that line, what thing will it sweep out? What is the three-dimensional shape which I get? Simple things like this is what I'm talking about. Simple things like you would have seen a cone being cut by a simple pieces. तो आपको पता है कि अगर हम कोन में ऐसे काटेंगे तो मुझे कॉनिकल शेप कौन सी मिलेगी? मुझे सर्कल मिलेगा, मुझे इलिप्स मिलेगा, मुझे पैराबोला मिलेगा. लेकिन अगर वैसे ना काट के मैं किसी और तरीके से काट लूं तो क्या मिलेगा? या किसी और तरीके से उसको एक्सटेंड करूं तो क्या मिलेगा? Simple observations. These are the observations that I want you to just think about it. Even while sitting in front, whatever things that you have around you, just imagine why does a chair have four legs? There is a tripod stand as well, which is equally stable. If a tripod is equally stable and a four-leg chair is also stable, then why are the manufacturers wasting their money in creating one more leg to something which is so stable? आप तीन उस पे स्टूल पे भी तो बैठे हुए हैं, उस पे भी आप कभी नहीं गिरे, तो फिर ये मैन्युफैक्चरर्स के दिमाग में क्यों नहीं आता है? वो एक लेग लगा के अपना काम क्यों बढ़ा रहे हैं? ट्राइपॉड पे ही बैठ सकते हैं अगर हम वो भी तो उतनी ही स्टेबल है. चेयर के ऊपर एक लेग कॉर्नर में लगाने की और क्या जरूरत है? These are the things that I want you to. There is such. I'll show you some videos, of course, but what I wanted to, put a little background to it is, have you ever wondered? Now, there's a question for you. Have you ever, you must have seen pages when you flip pages through a book. I'm sure you all would have. Just make a guess, all right? Just make a guess. I want you to use your chatbots if you want to, chats if you want to. If I look at any page at random, or if you read any page at random, which digit from 1 to 9 is most frequent to come? कभी सोचा है? रोज किताब पढ़ते, अगर फिगर्स में हम बात करें, किताब में जहां पर भी फिगर्स लिखी होंगी या जहां पर हम पॉपुलेशन की या किसी की भी बात करते हैं, 1 से 9 तक का यानी मोडल डिजिट कौन सा है? 1 सबसे ज्यादा आता है, 5 आता है, 7 आता है, 8 आता है या 9 आता है? जस्ट मेक अ गेस. डोंट गूगल, बट जस्ट मेक अ गेस एंड देन आई विल टेल यू व्हाट इट विल बी. अगर आप कभी भी किताब पढ़ते हैं जहां पर कुछ भी डेटा के बारे में बात होती है, कौन सा डिजिट मोस्ट फ्रीक्वेंटली है? डू वी हैव सम रिस्पॉन्सेज ऑन द चैट्स? I've opened the chat. Varsha has written 7. Varsha, was that a guess or is there a logic?
I just guessed because I remember, turning over the pages and I see 7 many times. It's basically from personal observation. Yeah.
Let's go with Varsha first. Varsha, why 7?
Hello, can you hear me? Hello?
Varsha, you were the first one to answer. Why 7?
Am I audible?
Yes, you are.
Yeah, just pure guess. Basically, from coming from personal observation that whenever I'm turning pages, 7 occurs most of the time, or maybe something that I can remember.
Okay, okay. Good, at least you made an attempt. Many people have said 1. I don't know why they said. Anyone, if you can open, maybe Kriti or Saloni or Astha or Chandra. Kriti, you're not a maths person, but that's interesting to know that you've said 1.
Am I audible?
Yes,
Yeah.
you are.
It's a random guess, I guess, I think. But I think whenever I see a number, there will be, if mostly it's like 1 digit नंबर होगा तो 1 से कहीं ना कहीं शुरू होगा, नंबरिंग होगी अगर तो। और अगर कोई लाइक, क्योंकि जब हम आते हैं 11 12 उसमें भी 1 बहुत फ्रिक्वेंटली दिखेगा। और कभी हम बड़ी डिजिट भी लेते हैं लाइक थाउजेंड्स और समथिंग इन लैक्स और मिलियंस इवन, तो 1.2 इस तरीके के नंबर्स बहुत दिखते हैं, तो आई गेस 1 इज द मोस्ट फ्रिक्वेंट।
Okay.
Another response from Sona. Number
ठीक
3.
है, Saloni. Number 3, yes. Random guess. Okay. Sona has also made a random guess. Oh, well. So yes, you know it. What I'm pleased about it, at least you're thinking, and I'm sure you will go back and see. You will Google it. Do you see how simple things can be observed? These are simple things. I will tell you an answer, but there's a law on this. It's called Benford's law. Now you can just Google and see it. Benford. I'll put it up here. It's called. So there is a mathematical reason, of course. There is a probabilistic reason to this. It's called Benford's law. Those who've made a guess, you'll be glad to know it is 1. But why is it 1, and how can you prove it to mathematics, not just guessing? So what I'm trying to say is that people would have taken this into an observation, and they would have then substantiated with examples and then again examples. एक simple observation से ही शुरू होगा कि किसी के दिमाग में ये आया होगा कि ये number 1 बहुत ज्यादा आ रहा है क्या? They would have then seen it a little more experimentation, a little more observations, and then some mathematics would have gone in, some higher mathematics, which I don't know how many you would be familiar with. That's okay. It doesn't matter whether you know higher mathematics or not, but just a simple guessing, and why you placed 1 as your simple guess, which you are close to for whatever reasons, but you have done some mathematical task in your mind. You know what? Even using this term random, that also has a mathematical basis to it. Do you know that? जिसने random लिखा था, सोना ने लिखा था. When we use this term random, we don't. What we mean by random, what I'm trying to say is you've used this term random as arbitrariness, but just without thought. That's what you meant. But this word random also has a very significant mathematical connotations. आप रैंडम शब्द भी अगर यूज करते हैं तो रैंडम का भी मतलब है देयर इज अ लॉजिक बिहाइंड इवन क्रिएटिंग रैंडमनेस. तो मैं आज की टॉक में बिल्कुल बहुत डीप में नहीं जाऊंगी, बिकॉज आई वाज आस्क्ड बाय द ऑर्गेनाइजर्स कि हम बहुत सिंपल काम करेंगे, बहुत ही सिंपल. और इसका अगर हमें आज की टॉक थोड़ी सक्सेसफुल रहेगी तो हम इसके ऊपर एक सेकंड टॉक करेंगे जिसमें हम थोड़ा सा हाई पे चले जाएंगे, वेयर आई कैन प्रेजेंट यू दिस इफ यू आर रेडी टू डू सिंपल हाथ से. आज मैं सिर्फ वो कहते हैं ना एक ट्रिगर करके आप लोगों के पास छोड़ दूंगी बस. हम ज्यादा नहीं करेंगे because I don't want you to feel sleepy in this 1 hour. In any case, it is after lunch. Just these simple things. Okay, so now that you've ready, so it's called Benford's law. Do Google it, and it's based on probabilistic work. It's based on algorithms. जो आपने कभी पढ़ा होगा या देखा होगा, लॉग्स के बारे में कोई बात भी की होगी और नहीं भी की है, it doesn't matter. It just doesn't matter. What matters is that you have an observation to even see this. Okay, another question which came, across my mind many years back, which of course my grandfather had asked once. You would have done this. I'm sure you would have done this. अगर नहीं किया तो ये आज मैं आप लोगों को एक छोटी सी observation है. One day my grandfather just in a very jovial mood, he asked me that I was what was it? I can't remember, but it was something like a case हुआ और वहां पर कुछ किसी को कुछ डेथ वेथ होगी और whatever, there was somebody was killed, and the investigators were called for investigation. While doing the investigation, the detectives, they gave the entire thing, what happened there, with the quote. I don't remember it precisely, मुझे मैं थोड़ा जितना याद आ रहा है मैं उतने से आपको बता रही हूँ. So he said, चेयर यहाँ पड़ी हुई थी, वो कोने में उस तरफ पड़ा हुआ था, ये यहाँ पड़ा हुआ था, और टेबल पे एक गिलास रखा हुआ था, गिलास में इतना पानी था, और जो डेड बॉडी थी वो इधर पड़ी हुई थी, वो इस पोजीशन में पड़ी हुई थी, एक हाथ आगे था, एक हाथ पीछे था, एक वहां पर एक किताब खुली हुई थी और उसके जो पन्ने थे वो 18 और 19 खुले हुए थे, और जो डेड बॉडी थी वो उसका लेफ्ट हैंड जो था वो वाज ऑन द टॉप ऑफ द हेड, एंड सो ऑन एंड सो. Something what I've said, there was something which the judge said, you said something wrong. He said, आपने पूरी तरह से इन्वेस्टिगेशन नहीं की है, आपने कुछ एक चीज गलत बोली है, कुछ एक ऑब्जर्वेशन है वो गलत है. कोई छोटा सा गैस कर सकता है क्या गलत बोला? अगर आपने मुझे थोड़ा सा भी ध्यान से सुना होगा, कोई एक ऐसी चीज है जो जज ने बोला कि नहीं तुमने कुछ गलत बोला है.
Hand placement. First you said that the एक हाथ आगे था एक पीछे था, and then you said that one hand was on top of the head.
But I'm glad you're hearing. बाकी लोग सुन रहे हैं, ये सिर्फ क्वेश्चन इसीलिए था कि आप सुन रहे हैं मुझे.
Is it the page numbers that 18 and 19 coming together maybe?
Yeah, 18 and 19 cannot come together. Whenever you open a book, the first page on your right is page number 1. So the odd page would be on this side. So it could be 17, 18, it could be 19, 20, it can't be 18, 19. So thanks, Ruchi, Ashu, and Lopa. I'm glad Lopa has also said the same thing. तो आप समझ रहे हैं ये छोटी छोटी बातें जो है, and often my grandfather used to give a lot of these things, which simple observation. मैं आपसे वो पैटर्न्स और इन सब की बात नहीं कर रही, आपके पास बहुत यूट्यूब चैनल्स है जिसके आप देख सकते हैं how mathematics in patterns. This is something that I wanted to put through in this lecture, that it is simple observations of what happens around you. Simple observations, and observations are it's depend upon how much keenness do you have to know the things. I'm amazed by some of my people who because I'm in administration, I get to know so many people around me. The people who are successful, they are so keenly observant. They can record. It doesn't matter whether you have a good memory or not, but they are so keenly observant. They can read your faces also. I mean, I'm sure that I'm sitting right now in a university office, and when I visit my vice chancellor, so from my face he can say that, madam, is something wrong. There's something, so he observes the face and tells me that, there's something that you are thinking about. And I see all these people who have been successful in their life have very keen observations. So with that little preface, we're already hitting 4 o'clock. I wanted to show you certain videos. I've done this before. There's not something new. These examples that I talked about were something new that I have. But in 2020, when the COVID happened, all these thoughts that I shared with them, there are a lot of things. कि plantation में जो पत्ते आते हैं वो Fibonacci में कैसे आता है? There are a lot of misconceptions around this, that nature is fascinated through mathematics. Nature nahi hai fascinated. There is a logic behind why those numbers come in such a thing that very resonates with Fibonacci. It doesn't mean that God is a mathematician. I've heard a lot of people saying that God is a mathematician, and these are because it exists in nature. But there are other aspects which create a logic behind this. So what I'm trying to show you now is a couple of videos that I created in 2020, because all these thoughts that I've talked to you, these are all part of a series that I wish to make sometime. Lekin us time pe 2020 mein, when we were sitting at home, of course, I was, I try to work all the time. At that time, I approached my family and I said, I want to do something. He said, why don't you make these little thoughts into a video? Why don't you create certain videos of it? And of course, I didn't know how to make a video. I'll tell you how hard we worked even to create a video. The first thing that I was told while making a video is that, and that came to my daughter, she said, don't make a boring video. Don't make something which people will not work, which will not watch. And to make a video, make anything which is very, very short, maybe a 2 minutes or a 3 minute thing. Because that's you can attract people with only this much of an attention span. उस समय इंस्टा मुझे बिल्कुल भी नहीं मालूम था. Now of course I've started using Insta. That time she said, the most effective videos are only 2 to 3 minutes long. That was the biggest challenge. The second thing, I always thought, like, I'm giving a talk right now, it's very impromptu. But at that junction, when I made my first video, it came focus. It was so rubbish, I couldn't say anything. Then I realized that I can't impromptu say anything, because that will need a lot of editing if I have to make just a 2 to 3 minute video. So I had to create something which was effective, would go for 2 to 3 minutes. So a script writing had to be done. So then I started writing scripts, and I wanted to delete, and then revising, the learning this. Just give me 1 minute and just close the door. Bad story. Sorry. So then the second part was writing a script. This I think also, then we again, a simple maths we had to do. How many words will I need for a 2 minute or a 3 minute script? Do I need to have a speaking flow in it? Do I need to, do I need to add certain poetic values to it so that it attracts the people? I don't know whether we succeeded in doing that or not, because I'm not a literary person. But and then of course, thirdly, a lot of research. You cannot pour something into on anything without doing a thorough research. It has to be right. So every video that we made took us almost a week, और वो तब जब हम घर पे बैठे हुए थे. अब तो बिल्कुल ही टाइम नहीं मिलता, because we're all working and spread out on our work zones. But I want to share some videos. My scholars have already watched this video a million of times, and they know what I'm going to say. But nevertheless, it's always a pleasure to share everything that I've done it so many years back. If I get time, I will go back and do certain more things. Any one of you, if you find them interesting, are welcome to help me in creating more such videos. So thanks, Chandra. So I'll open the first one. I'll pause the video for people, those who are not familiar. This is only for the people who will be watching it for the first time. Those who have watched it, please refrain yourself from answering. But those who will be watching it for the first time, this is for you. So that you just you use your brain on simple things like that. So the first video is very, very simple one that I created. Will I be able to share it?
Yes, ma'am. You can share.
Okay, so I'll just let me know. I've sent a request to Anu to share. Right. So is the screen visible? I'm visible.
Yes,
Okay,
ma'am.
so this is one of the first videos that we had done after a lot of hard work and homework. And if you can see, it is only 1 minute 39 seconds. Simple thing, it's a very common thing, but yet you see it because this was the first one. So see if you can, if the voice is also audible or not. Hello everyone. The coronavirus actually changed our life.
Yes, ma'am, it is audible.
It's audible? Okay, so then I'll continue running it. I took this opportunity to put some ideas that validated my very, very good. I'm a maths educator, very passionate in challenge things that you see. But the challenge is, do you see mathematics? Yes. Have you ever noticed a common football that you play? How many types of shapes are there? Are the black and white shapes on the surface of the different same? Are they identical? Do you have mathematical challenge? And so, if you've understood the question, this is a football, and I request all of you who have never looked at this video earlier, can you guess, the shapes that it had? There is a mathematical name also to this. वो मैं अभी इतनी terms में नहीं जा रही, but it has certain shapes on it, a black and white regular shapes on it. Can you guess the shapes on it, and if you know how many each shape exists? You can open your mic because I can't see the chats. I don't know whether I can be able to see the chat simultaneously or not.
Hexagons.
So all hexagons. You can open your chat because you can open your mic because I can't see the chats. Okay.
Ma'am, pentagon and hexagon.
Somebody said hexagon, circle, hexagon, and somebody opened it and said pentagon and hexagon. Okay, so we'll resume, and people who said hexagon, this is for you. Yes. Actually, that shapes are actually regular pentagon. A regular figure is one in which all the angles are same and all the sides are also same. So you will find your black shapes are actually regular pentagons, and each pentagon is surrounded by 5 regular hexagons. In all, there will be 12 regular pentagons and 20 regular hexagons. So next time when you kick your ball, you're actually kicking a complex network of 32 regular polygons. I hope you enjoyed this video. I'm going to come up with very more simple objects which you find in and around your house. Let's see if you have a mathematical life. So this was the first one that I had done, where we looked at whether. Sorry, there is some noise. Some other video started. I'm sorry. Just give me a minute. I'll stop. I'm sorry.
Ma'am, you can go and close YouTube. You can close YouTube.
That's correct. So this the first video that I created is a very simple topic, the pentagons, but hexagon and pentagon is not a regular shape. Astha, what do you mean by a regular shape? What do you mean by a regular shape? That's very interesting observation, but what do you mean by a regular shape? Astha, am I audible? Or are you still here? Yes, so shapes which have equal angles, you're right. Well, actually, there are regular hexagons, and the shape that I shared does have a regular hexagon, is a regular hexagon in which all the sides are equal length and equal angles. In fact, a regular hexagon, all the angles are of 120 degrees, and a regular pentagon is 108 degrees. So these are all the shapes that we used are all regular shapes. There is a specific mathematical name also to it. I'm not telling you. Please, this is simple observations that if I've triggered that knack in you, please see more. Please रिसर्च मोर। और इनफैक्ट आप ये भी देखिएगा, अगर आप इसके ऊपर मैं आपको क्या बताना चाहती हूँ कि ये तो मैंने एक छोटा सा वीडियो बनाया था सिर्फ पेंटागन और हेक्सागन को बताते हुए। आप इसके साथ और बहुत चीजें अगर आप ऑब्जर्व करना चाहते हो आप कर सकते हैं। जैसे कि फॉर एग्जाम्पल ये सिर्फ रेगुलर पेंटागन और हेक्सागन से ही क्यों बना है, कोई और शेप से क्यों नहीं बन रहा? मतलब रेगुलर हेक्सागन्स में ऐसा क्या होता है कि वो पूरी बॉल नहीं बना पाते? यूल बी वेरी हैप्पी टू नो ऑल दीज थिंग्स। ये कोई बहुत बड़ी मैथ्स नहीं है, सिर्फ एंगल सम प्रॉपर्टी को यूज करके। और एक सॉलिड एंगल क्या होता है? जैसे एक फ्लैट एंगल होता है जिसमें 360 पूरा कंप्लीट होता है, इसी तरह लेकिन जब हम उसको बेंड कर देते हैं तो सॉलिड एंगल बनता है। सॉलिड एंगल क्या होता है, उसकी भी प्रॉपर्टीज पढ़िए। Yes, so when you say because these shapes can't tessellate, madam, tessellation asta, tessellation is on a two-dimensional space. In two-dimensional space, pentagon and hexagon will not tessellate, but because they will not complete a 360-degree angle. But a solid angle can be created by them. So tessellation while tessellation is a concept of two dimension, same chronology or same analogy to three-dimensional space will come to making a closed angle. So I'm very happy that you're asking these questions, and I think that I've almost done with my talk because this is what I wanted to imbibe with you, that these are the simple observations. Can you see how many things are interconnected to this? You are now talking about tessellations. Tessellation में भी देखिए कि कौन से शेप टेसिलेट करते हैं। हेक्सागन्स भी टेसिलेट करते हैं कि नहीं करते? पेंटागन्स के साथ टेसिलेट करते हैं कि नहीं करते? लेकिन पेंटागन हेक्सागन के साथ टेसिलेट करते हैं। I've written an article on this. If you ever get time, so read. I've done a lot of work on tessellations, and there are 2-3 articles. One is in Azim Premji magazine. 2-3 articles are on Azim Premji magazine at right angles, which is a very famous magazine of mathematics. Extensively, where we've looked at which are the shapes which create regular tessellations, true tessellations, and then irregular tessellations. And then if you do not have a regular shape, even then you can tessellate. But all of them lie on a basic principle of covering the shape infinitely and completing a 360-degree angle. But however, if you mold them and try to create a three-dimensional shape, then this rule will not work. Then you will have to work on the rule of creating a solid angle. तो वो सॉलिड एंगल भी कितना होगा? क्या वो 360 से ऊपर होगा कि नीचे होगा? कितना, वैसे तो नीचे होता है, कितना नीचे होगा? क्या 180 से लेकर 360 तक सभी एंगल्स जो है एक सॉलिड एंगल बनाएंगे? जब इन सॉलिड एंगल्स देयर आर नो गैप्स इन इट, जैसे टेसिलेशन में कोई गैप नहीं, ऐसी सॉलिड एंगल में कौन से गैप्स नहीं होंगे? So I think these are the things that you need to observe, and you'll get lot of geometrical shapes which are in and around us. You will not even realize. In fact, when I look at the a circular ball also, then also there are a lot of things that are related to it. In fact, now that we are working on football, there was another idea in my mind that there are different types of balls. This is a random question that I want to place it to you. There are different types of balls. There are volleyballs, there are basketballs, there are footballs, and many other such balls. Let alone, I'm not talking about the sprinter, just simple these 3 balls. ये 3 balls में से सबसे ज्यादा वॉल्यूम किसकी है? और ऐसा क्या है कि हम एक तरह की बॉल को एक गेम के लिए रखते हैं? So what I want to ask you is, how is a volleyball different from a basketball? How is a basketball different from a football? What makes them different? Why this particular ball is used to play a foot thing, and why something like a volleyball is used to play with hands? What is the difference between them? Is it related to density? Is it related to the shape? Shape, of course, is same. All of them are circulars, but they do differ in their sizes. But just the difference of sizes, how does it affect them? How does it affect the play? So if I have to go to a little nasty terms, what if in a game I replace a basketball with a football? Will the players find observation इतनी इंटीग्रेट करती है, मुझे इतना मजा आता है ये सब देखकर और ये सब सोचकर कि ऐसा ही क्या है कि हम यही वाली फुटबॉल को यूज करें। आप इसके बारे में एक बार सोच के देखिएगा। इनफैक्ट मैं आपको और भी चीजें बता सकती हूँ, जो छोटी छोटी चीजें। आप कैरम खेलते होंगे, कैरम में जो बड़ी वाली होती है, दैट्स ऑलवेज फ्लैट, whereas the pieces of the carom have a little zigzag, not zigzag, but they have little curves in them. Why? Why did they have these little gaps in those or those curves in it? What would happen if all the pieces were same? And why is the striker so smooth? Why are the others not made so smooth? Why do we have to replace the striker more often than the pawns? Just think about it. कुछ भी नहीं है, simple maths है, कुछ नहीं है. मैं जवाब नहीं देना चाहती because मैं चाहती हूँ कि आप लोग अरे गूगल ही करके देख लीजिए, बहुत simple है. Okay, so these are the simple observations that you need to have, which will lead you to so many interesting aspects, which don't need heavy maths, believe me. Simple class 10th tak ki maths, not 5, but simple class 10th. So the grooved pawn, the prawns have grooves. Yeah, now I can recall the name, the grooves. Why do the pawns have grooves and not the striker? सोच के देखिएगा, अगर कुछ आपके दिमाग में आ रहा है, then write it in the chat box that why are there grooves on the pawns but not on the striker. Think about it and let me know. By the time I'll open the next video, which was the next in my series, I just opened the next one. The next that I had prepared. So that was the first one, and if you could see, we had to work a lot in even finding the pictures of a football and then spinning it also. It needed a lot of work and a lot of animation and all this to be learned. We'll have to find my video again. Second one. Yeah. So let me share it first. Is it visible? There's a cup. Is it visible?
Yes, ma'am, it's visible.
Okay. So it says I for chai. Of course, we had to rhyme our things, and everything that you'll see was shot, photographed by us, recorded by us at home. Well, friends, in this episode of Do You Have a Mathematical Eye for Chai? So if you're a fond tea lover and like to have your tea through tea bags, you would have noticed that different shaped tea bags available in the market. There is a pillow-shaped tea bag, a pyramid-shaped tea bag, a circle-shaped tea bag, and a stick-like tube. And here's the challenge. For the same amount and quality of tea leaves, which of these shaped tea bags will give a better view? Do you have a mathematical eye for the shapes? The quality of tea depends. So, any guesses? So, I've given you 4 options. Which one, for the same quality and quantity of tea, which of the tea bags will give you a better brew? You can open your mic again. I won't be able to see the chat, so you can open your mic and speak. Okay, any guesses? I mean, if you're writing, then please speak out because I can't access the chat. Since my videos are on, I can't access the chat. Depends upon proper brewing of the tea leaves and of course the quality of tea leaves. When we add hot water to the tea bag, the tea leaves in it swell, they move in a circular motion and ooze out their flow. More space will ensure a better brew. The pyramid shape just qualifies to be a better shape and it gives enough space for the ingredients to unwind, infuse, and expand properly, releasing maximum flavor. By using the pyramid-shaped tea bag, the manufacturers are actually in a different situation. They use less material, they use less amount of tea leaves, but get a better brew. And of course, the shape of the pyramid is so attractive that it can be made expensive. Hope you enjoyed this little math in your cuppa. Chai time! Okay, I'll have to close the... the voice of the video was it not audible? Should I do that again, or I can speak also? Would you like me to repeat what was there in the last video?
Yes, ma'am.
So the question that was there, if you've seen the video, you've seen the graphics. So we had asked that there are 4 different types of tea bags. There is a pyramid-shaped tea bag, there is a cylindrical tea bag, there is a pillow-shaped tea bag, and there are tube-like tea bags. So in case you have to, in case you have to choose one of them for the same amount of tea leaves and the same of course quality, which of these shape, assuming that everything is same, which of these 4 shapes will give you a better brew and why? So the pyramid shape, the pillow shape, the circular one, and the tube-like or the cylindrical one. So that was the question that I had asked. So of course the answer is that the pillow shape the pyramid shaped tea bag works best. One, because of the shape that it has, when you put it down with just simple, when you brew the tea, it needs space to swirl around. ये swirling जो है, जो circular वाला होता है, उसमें होती नहीं क्योंकि इतना space नहीं होता है. और जब आप वो pyramid वाले में डालते हैं, तो आप जो पत्ती डालते हैं, वो उसमें flavor with that pyramid thing, and pyramid shape looks attractive also. So by using a pyramid shape, the manufacturers are also at a win-win situation because it looks more attractive. लोग ज्यादा लेंगे, एक पिलो शेप होगा और एक पिरामिड शेप होगा, तो लोग पिरामिड वाला ज्यादा प्रेफर करेंगे, और उसमें कम कपड़ा मतलब कम मटेरियल से भी ज्यादा टी का टेस्ट भी आता है. And then they can claim it also. So it becomes a win-win situation. One, of course, it uses, and in fact, if you compare between the pillow shape and the pyramid shape uses less material. I'm not talking about a circular shape right now. The circular shape is not good shape because it's a very compacted shape और उसमें swirl होने का जगह नहीं मिलती है. So the tea leaves do not get space to unwind and swell themselves. So that's a little how the shapes matter when you create tea bags. That was it about. So did you understand it?
Yes, ma'am.
Okay, so the next one is, I'll show the next video now, which is, is my screen still on sharing? No. So the next one is one of my favorites. The next one is, while I'll tell you one of my favorites is because it deals with animals. So this is how we interpret maths in nature. So the next one was really, really close to me. We had to do, I could not, when I came across this concept, I was not too confident whether what I'm doing is right or not. So I have to do a lot of research in certifying that what I'm doing is absolutely correct. Issues. It should be technically and researchably right. So this one is, is it visible?
Yes, ma'am. It's visible.
It's called a tail of tails, which means it's about the tail on animal's body. So I just play it now. And let me know if it is not audible, then I'll please try to do something with the voice.
Everybody's talking about artificial intelligence today, AI. Machine learning is another.
Ma'am, I think another video is playing.
Yeah.
No, it's the right video, right?
The voice is not coming across.
So was it audible?
Ma'am, can you play it again because the voice is not audible from the video?
Please, I'll put myself on mute and let me know if this works.
No.
No, ma'am, it's not audible at all. You might have to turn on your audio.
Is it? So I think it's taking audio from my end and not from the video. Let me do it. Hello friends. Today we're going to talk about patterns on animal skin.
Now it's audible.
Varied skin textures and patterns. If I ask you to name an animal which has spots on its skin, probably you would tell me a leopard. And if I ask you to name an animal which has a striped body, I think a zebra would come to your mind instantly. Let's come to the interesting part of it. What about their tails? Is the tail of a leopard spotted or striped? Is the tail of a zebra striped or spotted? Animal which has a striped body but a spotted tail. Do you have a map? Well, it's quite. So I'm not sure. Did you get the question right? So it talks about that we've seen animals which have spotted bodies, and we've seen animals which have striped bodies. A spotted body is like a leopard, and a striped body is something like a zebra. Have you come across the other way around? What about their tails? Have you seen an animal which has a spotted body or a striped tail, or vice versa, whether you've seen a striped body with a spotted tail? तो क्या ऐसा संभव है कि जो बॉडी में होगा, मतलब चारों कॉम्बिनेशन हो सकते हैं? अगर बॉडी स्पॉटेड है तो क्या टेल भी स्पॉटेड होगी? बॉडी स्ट्राइप्ड है तो टेल भी स्ट्राइप्ड होगी? दूसरा, बॉडी स्पॉटेड है, टेल स्ट्राइप्ड, बॉडी स्ट्राइप्ड है और टेल स्पॉटेड, और इनमें से कौन सा कॉम्बिनेशन संभव है और कौन से बिल्कुल संभव नहीं है? That's what we are talking about. And I could see that I've already taken almost an hour, so I'll just run the video without taking your observations on it. By the way, when I said this particular video is one of my, there are two videos which are very, very close to my heart, and this is one of them. As you can see, we worked very hard on the animation and a lot of research. So mathematically, how we explain it, that's what I'm going to say here. Possible of an animal. Let us start it. Logic to computers also give a differential equation in which by changing the parameters, one can explain this conjunction. The man is Alan Turing. In simple terms, Alan Turing's theory of morphogenesis goes something like this. Two chemicals, let's call them a reagent and a diffuser, interact to influence skin patterns. It stimulates the production of one color, the diffuser suppresses it. There is also a relationship between the shape and size of the skin area on which this reaction occurs. Squarish regions of roughly the same overall area give rise to spots. Long, thin regions lead to stripes perpendicular to the length of the region. The diffusion process takes place at the development of the embryo. Since the embryo of a zebra is thin pencil-like, it leads to stripes, whereas leopard's embryo is fairly chubby and therefore gives spots. Its tail, however, is thin and pencil-like, so the resulting pattern is stripes. This is how nature can be explained through mathematics. Love nature, love maths.
Haneet, the voice wasn't very clear. So can you just say, summarily?
All right. Okay. So in this video, of course, I will explain that we are looking whether there is a possibility of having a spotted. So when I talk about the theory of morphogenesis, which talks about that, when a body shape, the colors are, spread out into a body, there is a reagent and there is a diffuser. Now the spread of the reagent, so one is a reagent and other, of course, as the name suggests, a chemical diffuses it. In this theory of morphogenesis, if whichever dominates, that decides the most dominant color. If you have the same region, in a squarish region, you will have more spot-like body. But if you have the reagent the diffuser would be in the spots. If the shape is thin, pencil-like, then the diffuser will diffuse it horizontal, perpendicularly to the length of the shape. Since the embryo of a zebra or a horse is pencil-like thin, that is why their bodies have stripes on it. और इसीलिए बस टेल जो होती है वो पतली होती है तो टेल में स्ट्राइप्स मिलेंगे आपको स्पॉट नहीं मिलेंगे. You will never find a spotted tail. You may or may not find a striped tail, but you will never find a spotted tail because of the longitudinalness of it. That's what it talks about. And again, this is simple triggering. You please research it on your own and look at the theory of morphogenesis. It's extremely interesting, and it not just exists in animals, it exists in plants as well. So look at the spottedness of the plants. We get different type of plants. We get a red plant. We get plants which are, they have red on the top and green at the bottom. Why does that happen? How is that? How is the spread of the leaves? If the leaves are thin, like a palm leaves, then what are they? The length, the stripes, it also has a stripes parallel to the length of the leaf. But like which leaf then I talk about? The bigger leaves, where like a money plant, those big leaves, they will not have a similar pattern. So it's very interesting to see all this in nature as well, that how the area of the shape decides the spread of the chemical reactions that take place in that space. So this is something that I've tried to just touch upon them. मैं कहीं भी नहीं कह रही कि मैंने इनको बहुत डीपली मैं आपको बता रही हूँ. मैंने सिर्फ टच किया क्योंकि मैं आपको सिर्फ ऑब्जर्व करना बता रही हूँ. ये सिंपल ऑब्जर्वेशंस हैं जो कभी ना कभी मेरे दिमाग में आती थी. फिर मैंने बहुत पढ़ना शुरू किया, देखना शुरू किया और उसको देखा कि they are supported by some mathematical thing. Of course, there are other things also, multidisciplinarity बिल्कुल है, but it has something related to mathematics. So I'll go to the fifth one now, and I'll take the fourth one later. Okay, let me take the fourth one also. Now the fourth one is on face mask. Simple video. Why I'm putting this video is because this was while seeing these earlier videos. A person from Jammu Kashmir region, he wrote to me that he has observed something with his mask. And then I asked Yunus that you make a video and I'll put it up on my channel. So the Yunus is a teacher. He was a middle school teacher in Jammu region, and he's also made this video with very few resources. He got inspired by, and then he wrote to me कि आप मैडम इसमें मैंने कहा मैं नहीं बनाऊंगी, आप भेजिए और मैं उसको integrate करूँगी. So the fourth one is on face mask. Is it visible? Hello, friend. Is the video visible?
Yes, ma'am. It's visible. Yes, and audible also.
It's dedicated for public awareness. We're indeed going through a very rough phase. To protect ourselves from COVID-19, we need to clean our hands often, maintain a safe distancing, and use a good face mask. Let's talk about face masks today. This idea was shared with me by a teacher from Jammu region. He explains how a conical mask is better than a flat rectangular mask. I like the way he used minimum resources to make his point. Over to him.
Myself, Haneet Gandhi, teacher, High School Sindor, District 1, JNK. Want to share with you the idea how cup shape custom like face mask is better than face mask made up of cotton clothes. First, here this face mask, although it covers the whole face, but the distance between the mouth, nose, and this face mask is less than as compared to the distance between the mouth, nose, and face mask of cup-like face mask. When we exhale air, it is stuck with this cloth because the distance between the mouth, nose, and this cloth is very less as compared to this one. And naturally, the droplets of water can again go inside the mouth through nose, which can cause this viral disease.
Let me add a few more points. Conical mask being curved
is less stable for the droplets to stay on the outer surface. Also, owing to its curvedness, it fits better on the face, creating a seal at the nose and mouth. Well, the basic purpose of a mask is to protect you, be it any shape. The idea is to wear a clean mask which is hygienic and covers your face entirely when worn properly. Stay protected and let's pray for the well-being of all.
कोई आदमी बच्चे कहीं नहीं.
So this was again one of the observations just on face mask. It's a very simple thing, but effective because, I mean, yeah, what do I say? I don't think so. I need to say anything beyond what I've already shown. Is again just what kind of a face mask is more effective. Not that they do their job perfectly well, but just that if you use those, those medical face masks, the blue ones, they are flat. But then if you have a little curve on it, it doesn't allow the droplets to re-enter into your body and it gives them a little breathable space also. It's a simple topic, simple thing. Okay, so I'll go to the next two videos very quickly and then I'll open the house for questions. This was on shoelacing.
Today we're going to do some street maths, but first let me tie the shoelaces. I just realized that the shoelace style in both my shoes is very different. In one, there is a N zigzag pattern, while in the other, there is a crisscross pattern. And so I wonder, do mathematics have a role to play in shoelacing as well? In how many times can you lace your shoe? And which of these will give you a better fit? Which is more comfortable? Do you have a mathematics? Bogart Polster, a mathematician, has actually written a book on shoelacing, in which is given a wide variety of shoelacing styles. Let's discuss some of these in this video. I'm going to discuss three most common styles which are used for lacing the shoes. Firstly, the crisscross lacing. The most but the zigzag on the underline makes it a very comfortable and holds the foot together, whereas the upper lining gives it a very neater look. You will be interested to know that if your boot has 6 pairs of eyelets, you can actually tie them in 43,200 different styles. How many of these have you tried till now? Go on. 1, 2, lace your shoe.
So now I'll take the last one, which is on cutting the cake, and then I'll open the house for discussion.
Who doesn't like to have cakes? But what if I tell you that cutting the cake also involves some mathematical skills? There are good ways of cutting the cake and there are not so good ways of cutting the cake. The traditional way or the classical way of cutting the cake is by doing a wedge or making out a sector. So when you cut the cake, usually you put your knife in the center and you take out a wedge from it like this. Taking out the wedge or a sector like this part then gets exposed to the air and loses its moisture. Can you think of another way of cutting the cake? A way in which there is minimum exposure of the surface so that the cake doesn't get dry. Can you think of a mathematical way to cut the cake? While you think of so, I'll go and make another one for you.
Just on a lighter tone, for this video we took 2 days, and in 2 days we had baked almost 5 cakes. एक बार काटा तो वो crumble कर गया, दूसरी बार बनाया जल गया, then the video didn't come up. So in 2 days our house were only smelling of cakes. Just on a very lighter note. Now when I think about it, I feel so pleased and amused.
And here's the second cake to demonstrate the second myth. A British mathematician, Galton, said in the famous magazine Nature that to his amusement and satisfaction, the ordinary method of cutting out a wedge is very faulty. He proposed another way to cut the pieces so that the remaining pieces can be co-joined to give least exposure. And this was his method. So here's my cake, and I'm going to slice it from one chord. Parallel to it, I slice it again. You take out the slice and eat the cake. The remaining part can be joined so that there is least exposure. Now, when you join this, you can keep it together or put a rubber band around it so that it doesn't get exposed. Next time, when you have to cut the cake again, put another slice here. The next one parallel to this. My cake is a bit crusty, so it's crumbling. I have these pieces. Co-join the remaining part. You would see that there is least exposure to the surface and it remains perfectly moisture. Well, whatever the procedure may be, cutting the cake has to be a cakewalk, and I'm going to enjoy it.
So that's all from my side in today's. Sorry, let me close the YouTube.
Thanks,
So
Haneet.
that's all from my side on these 6 videos. Simply making a point that mathematics is so beautifully in and around us. You just need to have a little observation of the things which exist around you. That's it. Just a bit of, looking at the shapes, looking at the data which is around you and having that little curiosity to dig more. That's all. We can take the questions.
Yeah, thank you, Haneet. It's really interesting to watch these videos, like these are like part of our everyday world. And not that everybody thinks, mathematically, though they do engage with some kinds of thinking that suppose the football, the shapes one sees, but, thinking about those shapes in mathematical, term, not everybody does. And it's really interesting to see how you are discussing those objects. It's now open to questions and comments. I just have one query, which you can answer at the end. How does, like, we all are curious animals, like we are wired for curiosity, but that becoming mathematical in nature, like raising some mathematical questions. What kind of, like probing or dialogue one may initiate, say in the classroom or in the everyday world, to create a kind of, propensity to look at objects in specific ways. What kind of dialogue we can encourage in classrooms or in our everyday world? But you please answer it at the end. Let's take questions from others. Okay, now the session is open to questions and comments. So please unmute yourself, and you can also switch on your video so that Professor Gandhi can see you and talk to you. Please. Varsa, you can also write questions in the chat. Varsa, can you help in reading out the questions if anybody writes?
Yes, ma'am, I'll do that. But up until now, there are no questions in the chat box. I'll let you know. Yeah.
Nobody has any question?
So this itself is an indication of not being observable. एक क्वेश्चन कुछ तो आया होगा, कोई एक क्वेश्चन तो आपके ज़हन
comments से शुरू करिए, like if anybody has any comment or anybody has experienced anything in one's everyday life which is similar to what Professor Gandhi was talking about. Some dialogue we can start. I see Mansi, Ruchi, Indu, Dipti. Many of you work on mathematics. Can you? Akash has something.
Yes.
Can we magnetize the thoughts of students? Yeah. The question is, how can we mathematize the thoughts of the students?
I think similar to what Professor Niti Panda had asked. So I think I'll take this question because this has now come up. And of course, it's a very significant question also. So there are, of course, these little things that, you need to build observation. Like I said, my grandfather used to ask me several times, he used to pose these little questions, puzzles, everything to me. Often I could not answer, but now when I think of them, they of course introduced a little curiosity in me. So whether we were, on whatever we were doing, he used to just, and sometimes it used to be some nonsensical punch also, to be honest. Sometimes it used to be a nonsensical punch also, but just that he asked. So as adults, it's just that you ask. That's one. The second is that you need to have questions which go beyond it. Like, for example, if you're a school teacher and you don't have time for any of these observations, even then you can do a lot of problem posing. And for a very long time, all mathematics educators, if you look at the last curriculum framework, now I'm coming on to completely maths education. If you look at the last curriculum framework, if you look at the now, what things are happening, this phrase is catching up problem posing. But one needs to understand what do we mean by problem posing. सो प्रॉब्लम पोजिंग का मतलब ये है कि आप पहले तो बच्चों को जब हम सिंपल मैथ्स भी पढ़ा रहे हैं तो कुछ एक प्रॉपर्टीज होती है जो वेरिएंट होती है और कुछ इनवेरिएंट होती है which restrict your domain to do things. So for example, if you're talking about some numbers, their properties are valid only in that domain and it may not function at the next domain. But keeping the invariant intact, how do you change the variant part of it? मैं इसका एग्जाम्पल देना चाहूँ तो if I can give you an example, yes, we had done a lot of things. Yes, there is a famous article that we wrote long back with one of my scholars who's also joined in here, Neha, and I did that. So there was this, what we simply observed, there was a question in the textbook that I don't remember, that it's published in Azim Premji at Right Angle. So it was a question that if there is a person who's going round and round in a spiraling manner, all right, and then the length of the spiral, I think it was class 9th, and the spiraling is of course in a circular manner, which always is. So at that point we said that what if in this question, instead the question had some variance and some invariant. The first thing was that there is somebody who's going in a circular manner. So we said, what if we change this property of going in a circular manner? Let the boy or the object go in a square. Then what would happen? Will the property or will the generalization still hold? तो हमने उसका बेसिक चेंज कर दिया, सर्कल से उसको स्क्वायर पे करके देखा. स्क्वायर पे करके देखा तो क्या होता है, अगर स्क्वायर की जगह में हेक्सागन ले ली, तो मैंने रेगुलर शेप में ही हमने काम किया था, स्क्वायर हटा के हमने रेगुलर कर लिया, तब क्या होगा, वो जिगजैग जाने की जगह वो इस राउंड में ऐसे स्पाइरल जाने की जगह वो ऐसे स्पाइरल जा रहा है, तब क्या होगा, अगर वो डायगोनली बैक एंड फोर्थ करेगा तब क्या होगा. So these are the things that we started exploring even from a textbook problem. So what I'm trying to tell you, in the classrooms also, you can just simply pose the problem कि ये अगर सर्कल में ना होकर स्क्वायर में होता क्या होता है. In that article also we concluded that we don't have the answers to this. Only because we were just doodling, we didn't get the answer to it. We said that we are not. I've lost touch of pure mathematics, being a maths educator for so many years. But I'm sure somebody would have read the article, somebody would find a solution to that, that there is something which it will lead to a generalization. Our point of work was only to tell you that how you pose a problem. Certain things, if you just trigger them off, अच्छा ये ना करके अगर ये करते तो क्या आता, 3 डिजिट ना लेकर बहुत सारे हम सवाल देखते हैं, आप 3 डिजिट का एक नंबर सोचिए, फिर उसको ऐड करिए, रिवर्स करिए, जोड़िए. 3 डिजिट का आंसर पहले इनवेरिएंट में चेंज कर देती हूँ, 3 डिजिट की जगह 4 डिजिट नंबर चूज करिए, बाकी सब सेम रखते हैं. There's a very famous problem which I do always with my maths classroom is 1089. You just Google this problem, 1089, the problem of 1089. It starts with 3-digit number. Think of a 3-digit number, reverse it, subtract it, again reverse it, and then add it. At the end, you get 1089. So what if, so there are steps. What if at the starting I say, no, don't choose a 3-digit number, choose a 4-digit number. And rest of the steps go as it is. You reverse it, you add it, you subtract it, rest of the steps go same. Do you still get a number? Do you still get a generalized number or not? Simple tasks like this can anytime be given to the students, which just tells you, ये textbook से ही निकाल के मैं आपको problems बता रही हूँ, कुछ अलग से नहीं बता रही हूँ, बाकी चीजें तो फिर भी अलग से थी. Simply helping students that this simple change this from this. Once somebody will have that knack to go beyond it. Once you've told them, तो वो घर जाके एक बार उसको करने की कोशिश जरूर करेंगे. And this is something, these projects are so beautifully done because you will not find, you can't Google the answer, because these are self-created. These are not shortcuts. The students will not go any project. Teachers इतने सारे project देते हैं, उनके सब कुछ Google पे मिल जाता है. Then you don't know the authenticity of this. Simple, if you do it from your classroom, there's no Google answer to it. For example, the questions that I've told you, you can try to whatever extent, you will not get an answer to it. There's no Google answer to this. So this is how you can mathematize the mind. Mathematize the mind doesn't mean you have to get an answer to it. It's just the way of thinking. Just the way of thinking.
Okay, thank you so much, ma'am.
Time constraint in classrooms, ma'am, of course, it's a difficult thing to handle. Often, all of us get asked by this, but जैसे मैंने भी आपको example बताया, आपको बस इतना करके छोड़ देना है, आपको इसका जवाब थोड़ी ना चाहिए. आप चाहते जो बच्चा सोचना चाहेगा वो सोचेगा, कभी ना कभी वापस आएगा और आपसे आके बात भी करेगा. और या उसको most appropriate, if you really have to make it a task, then give it as a holiday homework during summer vacation, if you ever wish to do that. But the most effective way is, you don't have, you have to follow up everything that you haven't, then you haven't triggered anything. अगर आपको उसको टास्क बना के फॉलो अप करते रहना है तो आप इसको, it's like the mother's love, it's only one way. You don't expect anything back from it because you're trying to engage somebody's mind, somebody's curiosity. That's it.
Okay, thank you.
I have my own observation. When we add 2 even numbers or 2 odd numbers together, we get even always. And when we add 1 odd number and 1 even number, it gives always an odd number. Is it proved? Yes, you can try it, and there are certain things. This is very simple work. You can simply try it, but again, Saloni, I want to point one thing here. जब भी हम बात कर रहे हैं, number itself, how do you define number? What is the range of number that you're talking about? Are you talking about 2 fractions? Are you talking about 2 real numbers? Are you talking about 2 complex numbers? That's what I'm saying. There are invariants. This is an invariant property. Within this, there are then, ये आपका एक दायरे है और इसके अंदर फिर आप play around कर सकते हैं. Varish, yeah, Varish, thank you. It was an AP related problem. Now I recall while I was speaking. It was in class 9th arithmetic progression. You're right. Man being observant sometimes needs to get distracted from the normal course of life. How can we manage this imbalance? Okay, that's a little philosophical, and I don't get time these days to make these videos. I'm passionate about making these videos. I don't get time, but that doesn't mean that the ideas are not in my mind. They're still marinating in my mind. If I ever get time, maybe if I'm through with this heavy task of teen admissions, if I ever get time, but not that I'm not thinking. So of course, as I said, you don't need answers always. You just need to trigger the questions in it. So, but you may or may not get answers always. It's about making spiral. Yes, Neha. Yaad aa gaya mujhe. I was wondering to relate everyday mathematics, Miniti ma'am taught us, and your explanations. I don't know. I'll have to now attend one of Miniti ma'am's lecture to understand how she resonates with my work or how I resonate with her work. But since you are the one who have heard both of us, you can tell us. And it's good that we've got an opportunity to know each other. I'll go back and look at I've of course heard a lot about her. I've read her work, but now that you brought us more closer, we will interact to more about each other's work more in depth.
Thank you so much, ma'am, because we were reading her papers on tribal children and their mathematics, and a lot of her research papers. So I was just relating those things with your explanation. It was excellent. Very nice. Thank you.
She's done a lot of work on folk mathematics. Am I right, Professor Pandey? Area of a shape decides the spread of the chemical over it. Whose theory belongs to it? I'm told, but sorry, I'm missing it. Told, but I was unable to. Rashmi, just go to the video again. And this, if you type my YouTube, if you go on Haneet Gandhi, there are only 6 videos, and it's called Theory of Morphogenesis. So you can take a look at that and see how it comes. I would like to add to what. I would like to add to what Nan has just said. Try to make students learn mathematical way of thinking rather than teaching mathematics. Thank you. Okay, so the others are anything that I'm missing. It is always delight to listen to you. Ruchi, you would say that because you're my student.
Ma'am, there is a question by Sonjarya Minch. She said that however, unless the routine conversations include some of the mathematical concepts, is it still possible to mathematize a mind?
Sorry, I was reading the questions. What did you say, Varsha?
I'm just reading out another question by Sonjarya Minch. She has written, however, unless the routine conversations include some of the mathematical concepts, is it still possible to mathematize a mind?
So okay. Now let me clear this up, and Professor Panda would join me on this.
After you finish.
Mathematics doesn't mean there is number crunching. There are shapes. It's a style of thinking, creating logics. Argumentation is based on a logic. There are ways in which you are connecting. It doesn't mean that if I'm talking about mathematics or mathematics doesn't mean कि मुझे numbers के साथ ही कुछ करना है या मुझे shape के साथ ही कुछ करना है या मुझे probability के साथ ही करना है. It's a style of approaching things in a way. Professor Panda, would you like to add to that? I'm sure you will.
Yeah, we were arguing in late 90s and early this century that mathematics is not only about addition, subtraction, or numbers. It's also about quantities, their relationships, patterns, shapes. So it's about how we look at the world and think about them and the relationship between different, objects. So what it also at another level we talk about aesthetics, like when we look at the world, we also identify certain kinds of patterns, and that's part of larger aesthetics, which allows us to engage with the world with some bit of kind of satisfaction of beauty and so even when Professor Haneet Gandhi was showing this football and different shapes were there, they were not too random. If they were too random, we are wired for this pattern. So we start looking for pattern, and then those patterns also give us a beauty. And theorizing those beauty actually is mathematics, because we are dealing with these mathematical ideas of sets or concepts or many of this. But, so maybe Professor Haneet Gandhi has to come back and take the debate to another level. That is when Professor Sona Jharia means question can be responded. What Professor Gandhi was probably trying to do was was to make us see how the world is actually organized, and we have an eye. I mean, we have a mind that can see the world in specific way or ways, and those ways are mathematical in nature, and it's like there is mathematics around us because things appear in some specific ways. There are regularities, there are patterns, we theorize them, but also we have the capacity to see them that way. We are wired for it. But then the question that I was asking in the beginning, which is where being a mathematician, being a psychologist, I think little more, is that okay, like on our own, we don't see everything. And also, like some see some of the mathematical objects or properties, and others don't see that very clearly, which was evident, when Professor Gandhi was asking, some of us were responding, and many were not responding. Not that those who didn't respond were not thinking in those lines, but we may not see those, things right away. Of course, like mathematical thinking requires seeing specific objects and relationship in certain ways, and also theorize those relationships. So the moment we get into that, once we start talking about say mathematics per se, what kind of mathematics is there, we enter into a kind of logical discourse, a very different kind of linguistic register, and also linguistic registers creating certain affordances to see the world in specific ways. I think that is where the challenge also lies, because we have to then talk in mathematical language. Uh, I think Professor Gandhi has to probably come back and take at least one such visual, one such visualization to a very systematic mathematical exploration. That is where, and also the kind of dialogue we require to engage students or even people in general in some kind of mathematical thinking. So what Professor Gandhi was trying to do is, okay, there is a lot of mathematics around us, and it's immensely possible to see some of them. But they in themselves are not mathematics, in the sense that we do not go to a level of our observation when, like the way you were talking about hexagons and pentagons using, say, angles. We don't think in that precise language. And that, thinking in those precise language requires some kind of pedagogic intervention, even in our everyday life. A lot of mothers try to do, educated mothers, and also they may not be educated, but they try to show us certain patterns, and then they try to tell us that this world exists. Also, I mean, we can conceive this world or see this world because we can think through patterns. We can minimize. We can actually put an order on this, world using patterns. So, and many, I've seen that in tribal areas, many not literate people, but educated, you can say, but not, the people who do not have literacy, but are able to talk about patterns or say ratios or quantities in very precise, folk mathematical ways. So I think, Professor Gandhi, when goes to the next level of dealing with these mathematical ideas that are visible to our naked eyes, and then talking about them strictly in mathematical language, would require some kind of intervention, which Sona Zaria means was trying to say that how do we, but Sona, mathematizing mind, I'm not very sure about this expression. We mathematize the world, what we see. And as we see and as we mathematize, we develop some kind of, logic. And those logic are accessible to us often in language. And we exploit those languages to even build a higher logic on it, And so what the mind gets is basically these logical tools, and sometimes we call them mathematical tools, But mathematization we do of the world outside. I mean, that's how we talk about that there is world outside, and we see them, and they're in kind of like, I mean, they're everywhere, things are everywhere. But then we see them in specific ways. And we talk about them also using some of those patterns. That is called mathematization. So, mathematization of mind, we psychologists don't talk about. I don't know about mathematics scholars, but normally we psychologists don't talk about mathematization of mind. We rather talk about acquiring many cognitive and linguistic tools that then scaffold higher order mathematical thinking. Does that mathematize our mind? I don't know. Yeah. Hanit, do you use this phrase, mathematization of mind?
Even I don't use. In fact, I've
Yeah.
hardly even when it was there in the curriculum. But of course, since it was there in the focus group paper, so we had to discuss. There are papers who've written on demathematization. So there's a lot of debates being done on this. But
Okay, mathematization then, okay, the logic is called mathematics then in that case.
we have to discuss this. So Professor Panath, the office has to be closed now. They're waiting for me. Actually, today there was a flash show in our university and we had a half day. I could not correlate both the things, but I committed, so I continued. So the office is waiting for me to log out so that they can close the office. I'm sorry, everyone. We'll continue with this if I get another chance. Those who are in Delhi, you're most welcome these days to University of Delhi. Our gardens are full of beautiful flowers and vibrant colors. Please visit Delhi University. This is the best time to visit University of Delhi. And I'm sure JNU as well. But I can vouch for university because today we are just, our gardens are so very boogie gardens. So thank you, Professor Pandey.
We'll get you back. I think, I had seen your paper on this cake cutting. Maybe you can take the debate to another level where you can discuss what kind of dialogue we need in the classroom, and also what kind of conceptual metaphors we bring to classroom or to any conversation where we aim at developing certain kinds of mathematical thinking in students. I think that part we can invite you again to do the second part of your talk. Because that paper I was looking at some days back, you actually have done that in that paper, yeah. So thank you, Professor Gandhi. It was wonderful having you in this lecture series, and we will upload all the videos. We are trying to start a website, so a devoted website where we put up all these videos so anybody can actually watch. And so let us know after maybe 2 months or so. You can always come back to this lecture series with next level, engagement. Yeah. Thank you, Professor Gandhi.
Thank you,
everybody, for joining us in this dialogue.
Thank you.
Thank you. Bye-bye. Thank you, Varsa. I forgot to thank you. Varsa was behind organizing this. Yeah.
So those who wish to get information for the upcoming webinars, please drop your email ID or email address in the chat box. I will add you in the Google group and you will receive the upcoming seminars.